So I'm going to go into a little background on Git, and to understand why we use Git and how it works, you need to kind of understand in general what VCSs are, which are version control systems. Okay, so I'm sure all of you have written essays before, maybe probably mostly on Google Docs, but maybe you've written one off like Word doc, right? And as you go through, you'll use a VCS, self-implemented manual one, which we're going to be calling a local VCS. Basically, as you write your essay, you'll have like essay rough draft 1, and you'll save that. You'll move it over, and you'll open up a new one, and then have essay rough draft 2, and then final, and then essay final, and like you'll keep saving up these copies of the drafts. You'll have like a history of your stuff in case you want to go back and change things. People who did this when they were writing code way back when, they'll just make copies of their code to save versions. And for the most part, it works. It's easy. You just have to copy something over. You don't have to think too hard about it. It's fully offline, so there's no network traffic. But in general, it does kind of suck. If you lose your computer, all your stuff is gone. It's really error prone. You could overwrite files on accident. And working with other people becomes a pain in the ass. Like imagine having to email copies of your code and merge changes with other people. It would be a pain in the ass. So in general, no one really does this, especially definitely not in the industry. So over time, developers came up with a better system, which is to use a centralized version control system. So instead of storing all the copies of your the file on your home system, they're like, okay, let's move it to a server. And we can store it on the server. And if I want a version, I can connect to the server, and the server will send me a copy of the file. The pros were, this is a minor pro, but you only have to store one copy of the file on your actual computer. But mainly what it opened up was administrators now had really great control over the project. Before it was like manually sending things between developers. This allowed project managers to look at who's changing what, when it's being changed. They can choose what should be changed, and it allowed the ability to collaborate, which was very important, as you can imagine. We don't want to be emailing each other files to to be changing things. The cons are it still has that single point of failure. If that server were to go down for like 3 hours, that's 3 hours of development gone. The other issue is we have this large network overhead where, say you wanted to look up a version of the file, you need to send that command basically to the server. Server needs to process it and send you a file back. So we're having a lot of network bandwidth being used. Because all changes are being handled remotely. So eventually we moved on to an even better system, a distributed version control system. So we still have all the version history for the file on that main server. What we're also doing is now copying it to each individual developer's computers. So that means if the server shuts down, instead of losing like a year, multiple years of work because the drive's corrupted, every single developer has a full backup of the project history. You have so much space on your hard drive, it really doesn't matter. Like it doesn't take up too much space. So that's basically the main concept of Git. Is we're going to have copies of files of all the versions of a file throughout every user's computer. And the other big difference between Git and other systems is how it thinks about data. So,
sorry, I'm just making sure it's recording.
So most VCSs before Git would use a difference or a diff-based system. So you'd start off with some base file like hello world, right? And if I were to make a change and I were to merge that change with everyone else's versions, how that version control system will think of it is hello world. And then if I add another line that says goodbye world, right? Kind of dark, I guess, but they'll have the original hello world file, and then insert new line goodbye world at line 2 or whatever, something like that. And say you wanted a later version, like version 4, what it would do is just apply all these diffs to get you that new version. The issue with that is obviously if you get some damages to any of these diffs, if any of that corrupts, to recreate the file, it's going to recreate it incorrectly. So what Git ended up doing instead is to use snapshots. Snapshots are basically an entire copy of that file for each new version. So say if you change the file, you add goodbye world, it's going to have the original file that says hello world, and then a new file that says hello world, goodbye world. And that's great because if I lose the later copies, like I only lose that file for that specific version. I still have all the ones before and all the ones after. There's more integrity for the data. Obviously, every time, if you don't change a file, it won't actually save it. So for version 3, you can see they didn't change file A1. So in the place of a new file, it's just a pointer back to A1. And same thing with file B and C. They'll just point back whenever you don't make a change. So that's kind of the snapshots, what the ideas are for that.
Click the screen.
The screen?
Yep.
Ooh. So yeah, this is just a summary basically. Gets a distributed version control system, treats its data as snapshots, and yeah, so just basically gives you data integrity, what we went over. The only way you're going to lose everything is if all our computers catch on fire simultaneously, as well as the servers at GitHub. So we're going to be pretty certain we're not going to lose anything. Yeah, pretty much thermo global nuclear war will be the only way. Actually, not even that, because GitHub has backups of a bunch of files in like a nuclear bunker. They did. They actually did this in like 2018. They took every repository that was popular enough, took copies of it, and stored it in like a nuclear bunker. So even thermal global nuclear war won't wipe out all repositories. It will for us. But oh yeah.
Oh, all these slides are going to be available. We'll
Yeah.
get them up to you.
Okay. And don't worry, you don't really, this is just something to kind of understand. When you're using Git, you're not going to need to think about this quite as much, but just so you can kind of understand where this is coming from. Now with Git, there's kind of 3 main areas that exist on your computer. There's going to be the Git directory, the staging area, and the working directory. So I'm going to draw on the whiteboard a bit. Git is kind of split into, for you as a user, 2 important areas. There's going to be basically the server, the centralized server. In our case, that's going to be GitHub. So we'll talk about that in a little bit. And then you're going to have all the stuff on your computer. On your computer, that's where you're going to have these 3 different areas. So the main one, or probably the most important one, is going to be the Git repository. This is just going to be actually where all those versions of the file live on your computer. So all the changes, everything that's been made, the entire project history is going to live in the Git directory. Thing is, you're not actually going to manually edit any of the files in the Git directory. What you're actually going to be working on is, fittingly enough, called the working directory. So that's going to be over here. So that's going to be where basically the folder that your IDE is going to be using to look at all the code. So that's going to have all your files like hello world.cpp or whatever, or .py.
We have a question.
What's up?
IDE integrated
Development environment, basically VS Code.
Okay.
IDEs, aside the difference between IDEs and text, basically an IDE is a text editor built in with a compiler, built in with a debugger. So you can write your code and run it and test it and debug it all in one place. So that's what an IDE
Would
is.
terminal be considered an IDE as well, or no, not really?
Well, it depends. You can, if you're using like Vim,
Yeah.
then Vim would be a text editor, but
Okay.
you can juice up with plugins, Vim,
Yeah.
and add like a compiler and a debugger in, and at that point it would be an IDE.
Okay.
But by default, usually not. Mike has some choice opinions about people who don't use VS Code.
I do.
We're just saying, I think what Mike said the other day is, I was like, oh, if people want to use Vim, they can. And Mike's like, oh, if you want to use Vim, more power to you. And you're going to need more power because you're going to be left in the dust with all the people using modern tools. So in general, it's probably best if you want to use VS Code, unless you're going to spend like hours upon hours juicing up a text edit, like a Vim or NeoVim or something like that. For you, probably a waste of time. I think you guys should just use VS Code. Yeah, so that's the working directory. That's just going to contain all the files you're actually editing. The next is going to be the staging area, which lives in between the working directory and Git. This is basically the staging area is where we're going to look for any differences between the files in your working directory and the most recent version in the Git repository. And we're gonna move all of those changes we want to commit or add to the Git repository as a new version to here. So if you want to like move your changed hello world, you would move it to the staging area, you give it a commit message, and then move it into Git. So staging area is just going to work where all the changed files are going to live. It's kind of more of an abstract area where you're just basically deciding what you're going to be committing to Git. And just in case you didn't pick it up, committing is just how we take changes in our working directory and move it to the Git repository. It's just called committing. You can kind of think of it like saving. It's kind of like saving your files to the Git repository.
It's how you make like a point in time that you want to save that version.
Yeah, it's basically a new version in that version history.
So like when we had the essay example and you're saying, oh, we're gonna say draft 1, draft 2, draft 3. When you went and created that draft 2, that's like the same thing as a commit. You're saying, I'm gonna want this point in time when I have this, my file looks like this at this point in time. Keep a history of this. That's what a commit is.
Or like a Google Docs equivalent. When you see autosave, essentially what it's or the equivalent would be Google is automatically committing your changes to a new version in the project history.
We have to do it ourselves.
Yeah, we have to do that manually, and you want to do it manually usually. Yeah, so then we need to talk about GitHub. GitHub, for our purposes, or for your purposes anyhow, is only going to be acting as that centralized server that's going to be hosting a remote Git repository. So basically, on GitHub, we're going to have a Cabrillo Robotics repo over here. This is going to be where all the code, it's basically the central point where all our changes are going to be merged to, and all of our changes. Anytime you want to sync up your Git repo with any changes other people have made, instead of talking directly to them, you're just going to talk to GitHub and pull the changes back to your computer. So there's a couple ways of, just to review anyways, Git is a tool and a version control system for keeping track of your computers. GitHub is a hub for Git. It's just a place to host remote repositories. There's some other cool stuff too, but you don't need to worry about that. Do you want to start moving into, should I talk about forking, finish my little diagram?
Yeah, finish your little diagram. We'll take a picture diagram and then we'll get that set up.
And on GitHub, creating a new remote repository, but it's also just another .git repository. The reason we do this is because a lot of times you're going to want to get your local changes off your system and save them remotely. Just because, again, if your computer dies, even though the project history is going to be saved elsewhere, your changes will be lost. So you usually are going to want to get them off your system onto the remote repo where you're going to know it's going to be safe. And from there, you can move your changes to the Cabrillo Robotics Git repository. Usually they have to get approved, which is why we just want to get them off our system and move them to your repo. Because there's different permissions for different remote repositories. As far as I'm aware, Orion is going to be pretty much the main person who's going to be controlling the main repository on GitHub. So if you write code and you try to merge it in with a Cabrillo Robotics Git repository, it might not get approved right away, it might get denied. So moving it to this remote server is a good way of keeping your changes safe on a remote repository. So in general, I'm just going to go front to back how all this is done, all of this is communicated. Basically, the first thing you all are going to do when you actually start writing code is you're going to go to the Cabrillo Robotics Git repository, and you're going to fork it to your own fork of the repository. From there, you clone the repository, which is just basically taking that Git repo and downloading it onto your computer here. From there, you're going to be able to have a working directory of files to change. So say, again, we add that goodbye world line. You then move it to staging, where you would stage the commit and create the commit, which moves it to your Git repo. Then from there, you're going to push it onto your fork of the repo. And from there, actually in the web browser on github.com, you'll be able to generate a pull request, which would be reviewed by someone on the team. And at that point, it gets merged into the Cabrillo Robotics.
Wouldn't that be a push request?
No. So here's the difference between push and pull. Most of the time, Git works on a pull-based system where you're going to be taking other people's changes and pulling it to yourself. In general, this makes sense because you don't want people changing your Git repo a lot of times without permission.
You're pulling your repo into the robotics club main. Is that what you're?
Well, you're requesting that that Orion pulls your changes.
I get it. Okay.
Pushing is basically when you say, fuck that, I'm going to force it in. You can't do that with the main repo, but you can do that with your fork. So since basically the only person working on your fork is going to be you, you can just push those changes and not worry about it. And from there, you request the pull. So for example, say CJ changes something and that gets merged into the Career Robotics repo. And now you're working with an outdated version. You then have to pull those changes to your repo, your remote repo, then pull that to your local repo. And then you'd be able to have all your files updated in the working directory and you can edit the most recent version. So that's kind of the whole workflow there. What's up?
So how do you know when you should re-update pull from the Career Robotics?
So, well, I mean, if you're actually looking at the websites for your fork of the repo, GitHub will actually tell you that your fork is a certain number of commits behind. So say you're 3 commits behind and there's a button that syncs your fork up. On your system, there's 2 commands you can use. Yeah, what's up?
Can you turn on like fork auto sync, or is that a bad idea?
I can see so in general, you usually should be. I would recommend taking manual control, just because in Git something you're gonna have to get used to is merge conflicts where you have a different version than the robotics club, and sometimes you're changing the same line, and we need to figure out a way of resolving those conflicts. So in general, you're gonna want to leave that up to your own discretion rather than letting GitHub or Git decide what to do. But on that note, Git, there's 2 commands. We'll go over this in a bit. Git pull, which basically on your local system pulls all the changes from the remote repository, which in this case will be your fork. And git fetch. Git fetch basically tells you about any discrepancies between your local Git repo and your fork, your remote fork. So yeah, just to recap one last time. To work on the code, you pull to your remote fork and pull to your local, and then work on them in your working directory. To get your changes out, you stage them, commit them to your local repo, push them to your remote fork, and then generate a pull request for the main repository. Does anyone have any questions or need anything to be re-explained? What's up?
Yeah, it's just a technical question. So on the server side, that is only web browser access, or is the GitHub desktop app, can that also?
I don't use the GitHub desktop app. I don't really know it.
You can probably see everything. I don't know. For a long time, they didn't have one for Linux.
Oh, okay.
So that might be a problem.
So you guys would recommend just learning how to do it in the browser?
I would. Well, no. So all of this to get everything to your fork. Yeah. I would recommend using the Git command line tool.
Yeah, I'm just talking about when we're actually working here on the server.
So I don't know anything about the desktop app. It probably does work for that. Okay. If it does and you want to use it, that's fine. I don't see any issues with that. If you don't want to download it, you can just use the web browser. If you want to use the desktop, it's fine. I would suggest probably I think you can generate commits and push your commits from the desktop, but I wouldn't recommend it. There's been instances the guy who made Linux, his name is Linus Torvalds. He also made Gits, and there was an incident where someone used GitHub Desktop to write a pull request, and it was formatted weirdly. And his response was, "What the fuck is wrong with you, you stupid piece of shit?" And basically tore this guy a new one. And you don't want to be the person who, I mean, obviously that was a dick move by Linus, but in general, there's a lot of people like that. You're kind of expected to use the terminal for that. If you want to,
You will not get that response from anyone here.
no.
And
Maybe
even Linus has seen the error of his ways.
yeah, no. But in general, it's no, it's not gonna happen. I'm not gonna do that to you. I know I give off a really intimidating, scary aura, but it's not gonna happen. But yeah, I would just recommend getting comfortable with the command line anyhow. It's really not that bad to use the command line. It's a little bit scary at first. But yeah, no, it is true that a lot of developers, for example, my dad's a software developer. He's been developing for like 30, 40 years. He uses graphical apps to visualize branches. We're not gonna talk about branches now because they're confusing, but there is kind of a stigma, like an idea that real programmers only stick into the command line. They don't use any graphical tools. It's kind of a little bit of bullshit. In general, I prefer the command line. If you guys want to use the desktop GUI app, then I'm not sure if that works.
I'll
It
say
might work.
real programmers get the job done right and on time.
True.
Period.
Yeah. So use what you want.
You know, you do it on the command line, you do it in the GUI, whatever you do it, real programmers get the job done.
Yeah, that's
And
true.
they might, speaking from experience now, not take a ton of shit, but again, it's only in service of getting the job done.
Yeah. Yeah, so I'm a little bit biased. I just like the command line. I think it's simpler for me anyhow. Really, once you learn pretty much Git, I'm explaining all this like higher level like design philosophy, but when you're actually using it, there's just a bunch of commands you memorize and you can just do them. Sometimes you have to think a little bit if there's a merge conflict. But really at the end of the day, what you're gonna be doing is to move any changes, you're gonna do the command git add dots, and then you're gonna do you do git commit -m in a message, and then git push. And that's pretty much all you do to get your changes from here to here to here to here.
Yeah, my apologies. I know I'm asking a lot of questions, but between the get and the pull, get to the fetch, there's a space there, right?
Yes,
In the
this is a space.
Okay, and then get.
Yeah, we're gonna go over this
Okay.
later. Don't
Okay,
worry.
cool. Sorry.
What's up, Mr.
Correct me if I'm wrong, because I forget. VS Code, if you are to sync Git with your VS Code account, then you can also commit from there just by pressing a button. I'm not sure if that.
There is so I haven't used VS Code's thing. That does exist. Have you used that, Mike?
For the VS Code for Git.
There's like the Git plugin or whatever.
Oh, yeah.
Workspaces.
It's good, it's easy. It does all the easy things and none of the hard things, which is exactly what it
Yeah.
But
Yeah.
It does your day-to-day work and all the extra stuff.
Yeah. Maybe I'll look into that. I've never used it. Maybe I'll look at it. And
It's
make a
actually
tutorial
the
for it.
only Git GUI I have ever used. And
Oh.
the reason is because in all of the other IDEs that I've used, the Git GUIs have been like super complicated and really tried to do everything.
Mm.
And all I really want is stage, message, commit, push.
Yeah.
Pull down new changes. That's 99.9% of what you're gonna do.
Okay.
And VS Code does that little, those flows, it does very well at the expense of having a bunch of extra stuff that you basically don't need. And if you do need, you can just as easily do it.
Yeah. Listen to Mike. Generally, opinions that diverge from his are usually not very pragmatic. So this goes for me as well. If I disagree with Mike, agree with Mike. Don't agree with me. In general, Mike is 99% of the time right about things. So just putting some credit on him. If you have any questions that I or Ryan can't answer, he's the person to ask. But yeah.
I mean, but that 1% of the time I'm lying on purpose.
So he's always.
Now you will know Is this that 1% of the time?
Just got seated out, but no, so yeah, anyway, yeah, so just like Mike said, pretty much your main workflow is gonna be git add, which stages them, git commit, which commits them to the repo, and git push, which pushes them to the fork. The rest is done off your computer. You can do it from, I think, the GitHub desktop app or from the website. But yeah, does everyone kind of get the gist? Cool. Let's see what we have next.